Good morning students. Today I am going to teach you the next topic, that is linear variable differential transformer. Okay, so this is the one type of transducer. It is inductive type transducer. Okay, so we know that transducer means it converts the physical quantity into electrical energy. Okay, so this linear variable differential transformer converts the displacement into electrical energy. Okay, this linear variable differential transformer works on the principle of mutual inductance. We already studied that one, mutual inductance principle. Okay, so here this one is the inductive type transformer. Then here the displacement is converted into electrical energy. Okay, so this is the circuit of this linear differential transformer. See, it has one primary winding and two secondary winding. Okay, so this is the primary winding and these two are the secondary winding. Okay, the primary winding is connected to the input AC voltage. Then secondary winding, the voltage across, it has two secondary windings, that is S1 and S2. Okay, then the voltage produced in the secondary winding S1 is VS1. Then the voltage produced in the secondary winding S2 is VS2. Okay, so the total output V0 equal to the difference of the voltage developed in both secondary winding. Okay, so that is V0 equal to VS1 minus VS2. That means difference between the two voltage. Okay, so it works on the principle of mutual inductance. Okay, so here we apply the AC voltage. Okay, so AC voltage in the primary winding. So the magnetic field is produced in that primary winding. Okay, so due to this magnetic field, because of this mutual inductance, the voltage is produced in the secondary winding. This both secondary winding. Do you understand? It is works on the principle of mutual inductance. Okay, so here we apply the AC supply in the primary winding. Then magnetic field is produced in the primary winding, and due to the mutual inductance, the voltage is produced in this secondary winding. Okay, so these windings are wound on the cylindrical former. Okay, so these windings are wound on the cylindrical former. Then the core is placed between this cylindrical former. Okay, so see, it has three cases. Okay, in first case, see, this is the core. This is the core part. This core part is placed symmetrical in both that S1, both secondary winding S1 and S2. Okay, that position is called as null position. Okay, so that means it is the voltage developed in this two secondary winding is same. Okay, do you understand? First, the core is placed symmetrically for both this secondary winding S1 and S2. That position is called as null position. In that position, and the voltage produced in the secondary winding S1 and the voltage produced in the secondary winding S2 is equal. That means VS1 equal to VS2. Okay, so the output voltage is 0. Do you understand? In null position, VS1 equal to VS2. We know the total output voltage is difference between the voltage produced in both secondary winding. Okay, so here the voltage are equal, so the output voltage is 0. Okay, then see, if this core is move above the null position, now this is in this core in the center position. If the core move above the null position, means the most of the core is near to this S1. Okay, so the voltage produced in the S1 is greater than the voltage produced in the S2. So that is VS1 greater than VS2. Do you understand? So VS1 greater than VS2 means, do you understand? If the core is almost the core is cover in this secondary winding S1. Okay, so now the core is move above the null position. Most of the core is in the secondary winding S1. So the voltage produced in the secondary winding S1 is greater than voltage produced in the secondary winding S2. So that VS1 greater than VS2. So the total voltage V0 equal to, here the VS1 voltage is greater. So VS1 minus VS2. Okay. Next, third case is if the core is move below the null position. Below the null position means the core in the secondary winding S2. Okay, so null position means the voltage produced in the secondary winding S2 is greater than voltage produced in the secondary winding S1. Okay, so that is VS2 greater than VS1. Now the output voltage V0 is, we know that the S2 voltage is greater. Okay, so VS2 minus V1. Okay, so these are the three conditions. Okay, in linear variable differential transformer, the displacement is converted into electrical energy. Okay, then it is works on the principle of mutual inductance. Then let's see the advantages and disadvantages of this LVDT. LVDT means linear variable differential transformer. First one is the excellent linear output voltage with displacement. Okay, so what is the advantage? Excellent linear output. Here linear output voltage with displacement. Here we get the linear output voltage. Then it has high sensitivity, then high resolution, then no effect of hostile environment since the unit is sealed. Here unit is sealed, so no effect of hostile environment. Okay, so these are the advantages of the linear variable differential transformer. Okay, so what are the advantages? First one is the excellent linear output voltage with displacement, then high sensitivity, high resolution, then no effect of hostile environment since the unit is sealed. Okay, then let's see the disadvantage. Okay, so here this LVDT is very sensitive to temperature changes and vibration. Okay, so these are the disadvantages. Disadvantages, what are the disadvantages? It is sensitive to temperature changes and vibration. Okay, so these all about linear variable differential transformer. Okay, so linear variable differential transformer is the one type of transducer. It converts displacement into electrical energy. Okay, so it works on the principle of mutual inductance. Okay, so this is the inductive type transducer. Okay, ma'am, thank you.